right, everyone, last video, and I think part 4 for section 4.6. So what I have written over here is just an example of what we have been doing. We've been given an equation and we've been finding solutions. So this is similar to what we did in 4.5, where we're working backwards. So they're going to give us the solutions. You'll notice this time our solutions will have i's in them. They'll be complex or imaginary solutions. And we're going to go backwards to an equation. So it says write an equation for a polynomial with the given roots. And remember, roots are the same thing as solutions. Write an equation where a, b, and c are integers. So that just means no fractions. We don't want to end up with an equation that has fractions. So the hint here is we're given the roots, or we're given the solutions, and we want an equation. So we're working backwards. So the first one says write a quadratic. So that tells me my equation should end up to be an x squared with the root 3i. So the first thing you have to remember is way back in video number 1, I believe, we said complex roots. So complex roots are the roots with the i's in them, always come in pairs. So if I have a root of positive 3i, I automatically have a root of negative 3i. So this is 2 solutions, even though they technically only gave me 1. 3i has to have negative 3i to go with it. They go together in pairs, they're never apart. So if you look over here, this is where we're at. We're at the end of the problem and we're going backwards. So what we have is one solution of x equals 3i and one solution of x equals negative 3i. So the step before that and all the problems we've done have been our 2 factors set equal to 0. So we want everything on one side of the equal sign and a 0 on the other. So what I want to do here is subtract 3i from both sides because I want a 0. And here I want to add 3i to both sides, just like we did in section 4.5 when we were doing these same type of problems. Okay, the step before this is where we had our 2 factors multiplied together and set equal to 0. Okay, so now I want to multiply to get my equation. There's another important thing we need to remember back from chapter 3. So let's put this right up here. So it's going to be I squared equals negative 1. So this is going to come up when we do our next step, this multiplying. So I squared, whenever we have an I squared, we're going to rewrite it or simplify it or substitute it into a negative 1. So now to multiply these, I think most of you prefer to do your multiplying 2 binomials using the box method. So there's my box. Remember to put this negative right next to this term so you remember it's negative. So I have x times x is x squared. Negative 3 times x, and there's an I in there too. So we just write these next to each other, almost like it has 2 variables. So I'm multiplying negative 3i times x, I get negative 3ix. Here, positive 3i times x, I'm going to get 3ix. Doesn't matter the order. You could also write 3xi. Here, negative 3 times positive 3 is negative 9. I times I is I squared. So treat I just like a variable here. I times I is I squared, just like x times x is x squared. Okay, now let's bring this out of the box and do some simplifying. So I'm just writing it all next to each other here. And there's a couple of things I see I can do. First of all, these are like terms. They have the same variables, if you want to think about it that way. They both have an xi, they both have an xi. And now I'm adding or subtracting. So if I combine negative 3ix and positive 3ix, I'm going to get 0. So those add to 0. So now I have x squared minus 9 times I squared. But remember our little note up here. Whenever we see an I squared, we have to replace it or substitute in a negative 1. So I cannot leave an I squared in my answer. So I'm going to say, well, this is the same as x squared minus, instead of 9 times I squared, substitute negative 1 in place of I squared. So now I have x squared, negative 9 times negative 1 is positive 9. So there is my equation, and I'm going to set that equal to 0, because we started out over here with everything set equal to 0. Okay, so just to recap, this is very important. If you have an I squared in your answer, you must substitute in a negative 1 in its place. It's okay to leave an I in your answer if that happens, but never an I squared, okay? So again, we're going backwards through this process. So complex roots come in pairs, so we added the negative 3i. So now we have two solutions, 3i and negative 3i. Next step, get everything on one side of the equal sign and 0 on the other. So we did that. You'll notice it's just a sign switch. Now take these two factors and multiply them. So that's what we were doing with our box. When you're multiplying, treat the I just like a variable. So negative 3i times x is negative 3ix, and I times I is I squared. Bring your answer out and combine like terms. These like terms added to 0, so those are essentially gone. Last step, cannot leave an I squared in my answer, so I substitute a negative 1 in its place and simplify. All right, that's a lot. It's okay, it's only the first one we've done. Let's try another. So this one's similar. It says write a quadratic equation, so I should end up with an x squared. And you'll notice in the last one we did end up with an x squared. And with the root negative 8i. So if I have negative 8i, they always come in pairs. I'm going to have positive 8i. Complex roots always come in pairs. Think of them like twins. It's got to be two of them, one negative, one positive. So my two solutions are x equals negative 8i, that's the one they gave me, and x equals positive 8i. Okay, now I want everything on one side of the equal sign, and I want a 0 over here. So to make a 0 here, I'm going to add 8i to both sides. So I'm going to get x plus 8i equals 0. And here I want a 0. So I'm going to minus 8i from both sides. So I'm going to get x minus 8i equals 0. Okay, so there are my two factors. Remember, this just looks like a sign switch. Now take your two factors and write them together as multiplication equals 0. And now I actually want to do the multiply. multiply. So I want to do the multiply. So I'm going to do my box right here. And I am multiplying x plus 8i and x minus 8i. X times x, x squared. 8i times x, 8ix. Just write them all together. X times negative 8i, negative 8ix. So it looks like I'm going to have that negative and positive thing happening again. Negative 8 times positive 8 is negative 64. I times I is I squared. Okay, bring your answer out of your box. X squared plus 8i, x minus 8i, x minus 64i squared. Think now I'm adding and subtracting, and so that is the same as combining like terms. These are like terms, they have the same variable. excuse me, raised to the same power. Add your coefficients. Well, my coefficients are positive 8 and negative 8, so that gets me 0. So these two terms are going to add to 0, so we're not going to write them. Now I'm left with x squared minus 64i squared. But remember, I squared is the same as negative 1. And I cannot leave that I squared in my answer. So I'm going to have x squared minus 64 times negative 1, which is going to be x squared. Negative 64 times negative 1 is positive 64. So that is my equation. So if I gave you this and told you to solve it, this is what you would get. 8i and negative 8i, two complex solutions. And also if you graphed this, it would have no x-intercepts because both of your solutions are complex. All right, let's try a little bit trickier one. So this has, looks like two roots, right? But notice it says write a cubic equation, x to the third. So that is a clue that I'm actually should have 3 roots. And here's why. Here's a complex root. It has to have its partner, has to have its twin. So there is my third root. X to the third should have 3 roots. So they're 5, positive 4i and negative 4i. The complex roots have to come in pairs. So my roots are x equals 5, x equals positive 4i, and x equals negative 4i. All right, for all 3 of these, we want a 0, a 0, a 0 on one side of the equal sign, everything else on the other. Something like this. So to make a 0 here, I'm going to subtract 5 from both sides, and I'm going to get x minus 5 equals 0. Here, to make a 0, I'm going to subtract 4i from both sides, so I'm going to get x minus 4i equals 0. And to make a 0 here, I'm going to add 4i to both sides, so I'm going to get x plus 4i equals 0. Okay, now let's write these all as factors multiplied together. Oh boy, this looks like a lot of work for multiplying, doesn't it? It won't end up to be that bad though. I'll tell you why. We're going to multiply these two first every single time. Your two factors with the complex roots or with the imaginary numbers in there, multiply those first. It will lead to a lot less work. When we get the answer from this multiplication problem, then we're going to multiply it by this. So we are going to do 2 boxes. If we do the box for these first, it makes life easier. So I'm going to do x minus 4i times x plus 4i. So I have x times x, x squared, negative 4i times x, negative 4i x, x times positive 4i, 4i x, negative 4 times positive 4, negative 16i squared. It's kind of small, hopefully you can see that. These are my like terms. Remember, you can check your diagonal for your like terms. And negative 4 and positive 4 add to 0. So these two terms are going to be gone. So I'm going to write my answer out here with just the negative 16i squared. Now, I squared, negative 1. So this is going to become x squared minus 16 times negative 1 instead of I, because I squared becomes negative 1, and that's going to become x squared plus 16. Okay, so this is important, but I'm not done. This is not my answer. The positive 16 came from negative 16 times negative 1. Now I need to multiply this by x minus 5. So remember, we started out over here with 3 factors. We multiplied these two, and we got x squared. plus 16. Now I need to take the answer from that and multiply it by x minus 5. So now I'm going to do another box, and I'm going to multiply x squared plus 16 times x minus 5. So be careful on these. There's lots of places to make mistakes, to miss a negative, or just lots of places to make a mistake. Put your invisible 1 on here so you remember x squared times x to the first is x to the third. When you're multiplying, you add the exponents. 16 times x, 16x, not bad. X squared times negative 5 x squared. And 16 times negative 5 is negative 80. Use your calculator if you need to. Now I'm checking my diagonal. These are not like terms. Actually, I'm looking at all these values in this box. It doesn't look like there's any like terms. So I'm going to take them out of the box. I'm going to write them in standard form. So I'm putting the x to the third first, the x squared second, then the 16x, then the minus 80. If you don't notice that when you're taking them out, you can always put it in standard form when you're done. So that one's done. There are no like terms. Let's add our equal 0 because this was a solve. We started with an equation. Equation has to have an equal sign. All right, so that's long for sure. Not so bad. The key here is remember to multiply these two, the factors with the i's, multiply those first, because those always simplify down into something nice. Let's try one more. Last one, getting to the end of 4-6. All right, so I'm writing a cubic, an x to the third, but hey, if it's an x to the third, why do I only have 2 solutions here? Because I gotta add the partner. If I have negative 6i, I have to have positive 6i. So my solutions are x equals 2, x equals negative 6i, and x equals positive 6i. Have to come in pairs. Okay, everything on one side of the equal sign, 0 on the other. That's going to become x minus 2 equals 0, x plus 6i equals 0, x minus 6i equals 0. Next step, these are my factors. Let's write them together as multiplication. All right, now I need to multiply all 3 of these, but I'm going to do these first. So multiply those 2 first, unless you like lots of extra work. If you don't like lots of extra work, multiply those 2 first. So x and positive 6i, x and negative 6i. I have a mistake in there. This should be a negative. Sorry about that. Okay, x times x, x squared, 6ix, negative 6ix, negative 36i squared. Common mistake is to just want to just write an I here and not an I squared. So make sure whenever you're multiplying those i's, you get I squared. Hey, look what's happening here. My like terms are adding to 0. First of all, my like terms are on the diagonal, and they're adding to 0. So I end up with x squared minus 36i squared, but I squared is negative 1. So I squared, instead of negative 36 times I squared, I'm going to have negative 36 times negative 1, which is x squared plus 36. Negative times a negative is a positive. Okay, this is important, but this is not my answer. My answer needs to be an x to the third power. This is just an x to the second power. I need to multiply that by x minus 2. So I multiplied these 2 factors. I got x squared plus 36. Now I need to multiply by x minus 2. So one more box. All right, here's my second box. Hopefully I didn't make that too small. So this time I'm multiplying x squared and positive 36 x and negative 2. X squared times x to the first is x to the third. So there's my x to the third, which is what I needed to have in my answer. 36 times x, 36x. This would be negative 2x squared. Hopefully you can see that there. And what's 36 times 2? Negative 72. Negative times positive is a negative. 36 times 2 is negative 72. So I'm just doing a quick check here. I don't see any like terms. I have an x to the third, an x to the second, an x, and a constant. So that's my answer. Let's just bring it out of the box. And when we do, let's write it in standard form. X to the third, this is a minus 2x squared, plus 36x minus 72 equals 0. So these are kind of involved. Great thing about video though, you can watch the whole thing again, and I actually encourage you to do that if you need to.